Hello everyone, welcome back to my channel again. So in this video again, let's solve one more problem from star delta transformation from the question paper December 2019-20 of ECA subject from video. Okay, so let us see the question now. Question number 2A. It looks like complicated now. Find R equivalent for the network shown across the terminals A and B, and all the values of registers are 10 each. Okay, you can see this. So I told one thing in a previous video, like if the three same values of registers are connected in delta, to transform that delta into star, you need to divide it by 3. ಅಂದ್ರೆ ಇವಾಗ ಮೂರ್ ಸೇಮ್ ರೆಜಿಸ್ಟರ್ಸ್ ನ ಡೆಲ್ಟಾ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ಸ್ಟಾರ್ ಗೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಮಾಡಬೇಕಾದ್ರೆ ಸೊ ಸೇಮ್ ವ್ಯಾಲ್ಯೂ ರೆಜಿಸ್ಟರ್ ಡಿವೈಡೆಡ್ ಬೈ 3. ಇವಾಗ 10 ಓಮ್ ನ ಮೂರ್ 10 ಓಮ್ ರೆಜಿಸ್ಟರ್ ನ ಡೆಲ್ಟಾ ಕನೆಕ್ಟ್ ಮಾಡಿಬಿಟ್ಟು ಅದನ್ನ ಸ್ಟಾರ್ ಗೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಮಾಡಬೇಕು ಅಂತ ಇದ್ರೆ ಸೊ 10 ಡಿವೈಡೆಡ್ ಬೈ 3 ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ R1 R2 R3. ಅದೇ ತರ 15 ಓಮ್ ರೆಜಿಸ್ಟರ್ಸ್ 15 ಓಮ್ ರೆಜಿಸ್ಟರ್ಸ್ ನ ಡೆಲ್ಟಾ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ಸ್ಟಾರ್ ಗೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ 15 divided by 3 ಅದು R1 R2 R3 ವ್ಯಾಲ್ಯೂ ಆಗಿರುತ್ತೆ. ಸೊ ಲೈಕ್ ದಟ್ ಅದೇ ತರ 3 ಸೇಮ್ ರೆಜಿಸ್ಟರ್ ಸೆಟ್ ಆಸ್ 5 ಓಮ್ ಅನ್ಕೊಳ್ಳಿ. 5 ಓಮ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ 3 ರೆಜಿಸ್ಟರ್ಸ್ ನ ಸ್ಟಾರ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿಬಿಟ್ಟು ಅದನ್ನ ಡೆಲ್ಟಾಗೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಮಲ್ಟಿಪ್ಲೈ ಬೈ 3. 5 into 3 is 15 is the values of RA, RB, RC. I hope you got my point. So now without wasting time, so I will take this problem. I'll just read it once again. Okay, A, B. So you need to convert, or else you need to transform this into a network in between A and B. That is equivalent register are equivalent. So first you convert this 10 ohm, 10 ohm, 10 ohm registers are in star from delta. So ಇದನ್ನ star will connect ಮಾಡಿದರೆ ಅದನ್ನ delta ಗೆ transform ಮಾಡಿ. All the values are same. So again ಆಗುತ್ತೆ R1, R2, R3. If I'm writing R1, R2, R3. R1 ಹೇಗೆ ಬರೀತೀರಾ 10 into 10 divided by 30. So R1 I will write it here. R1 is 10 into 10 divided by 10 plus 10 plus 10, that is 30. That is nothing but 100 divided by 30. 3.33. So ಈ ತರ ಆದ್ರೂ ಬರ್ಕೊಳ್ಳಿ, ಇಲ್ಲ ಅಂದ್ರೆ all the values are same. ಡೆಲ್ಟಾದಲ್ಲಿದೆ, ಸ್ಟಾರ್ ಗೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಮಾಡಬೇಕಂದ್ರೆ 10 divided by 3. So you can get 10 by 3 is the value 3.33. So ಇವಾಗ A ಇಂದ 3.33 ರೆಜಿಸ್ಟರ್, ಸಾರಿ ಇವಾಗ ನೋಡಿ A ಇಂದ R1, I will write from A to R1, R1 ಇಂದ R2, R1 ಮತ್ತೆ R2 ಮಧ್ಯ R3 ಇದೆ, like this. What is the value of R1 now? 3.33 ohm. R2 is also 3.33. R3 is also 3.33. ಇವಾಗ ಈ R3 ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀರಾ, it is connected to these junctions of 10 ohm, 10 ohm. So R3 ಇಂದ ಇಲ್ಲಿಗೆ 10 ohm ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀರಾ. So just use 10 ohm. ಅದೇ ತರ ಇಲ್ಲಿ ಇನ್ನೊಂದು 10 ohm ರೆಜಿಸ್ಟರ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀರಾ. ಸೊ ಇಲ್ಲೊಂದು 10 ohm ರೆಜಿಸ್ಟರ್ ಇದೆ ಸರ್ಕ್ಯೂಟ್ ಡಯಾಗ್ರಾಮ್ ಪ್ರಕಾರ. So this 10 ohm, 10 ohm, 10 ohm will go. For example, you can see now this will go, this will go, this will go. So now the circuit which looks like this, from A to R1, R2 to B, R3 in the ಇಲ್ಲಿ connect ಮಾಡಿದ್ರೆ. See, you can the circuit which looks like this. All the values are 10 ohm. 10, 10, 10. Okay. So now There is one more delta connection of 10 ohm, 10 ohm, 10 ohm here. These are connected in delta. You need to transform this into star again. So R4, R5 and R6. Okay. So now the circuit which looks like this. From A to R1, R2 to B, R1 and R2 values we already know, that is 3.33 and 3.33. In between R1 and R2 there is R3 of 3.33. Okay. So ಇವಾಗ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, 10 ohm 10 ohm 10 ohm ಸ್ಟಾರ್ ಸಾರಿ ಡೆಲ್ಟಾ ಇರೋದನ್ನ ಸ್ಟಾರ್ ಗೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. So now this R3 is connected in series to R4, and here we have R6, here we have R5. R5 is connected in series to 10 ohm now, and R6 is connected in series to 10 ohm. So if you want to understand now, you can see the circuit which looks like this. This 10 ohm, 10 ohm, 10 ohm will go. This 10 ohm and this 10 ohm will go. And it is replaced by R4 is connected in series to R3, R5 to 10, R6 to 10 like this. You get the circuit like this. So R4, R5, R6, all the values are 10. So that 10 divided by 3, that is nothing but this is also 3.33, 3.33 and 3.33. 10 into 10 divided by 30. So ಇವಾಗ ಏನಾಗುತ್ತೆ, R3 and R4 are in series. You add R1 and 10 is series. Sorry, R5 and 10 is in series. R6 and 10 is in series. You can get circuit like this. From A, you have R1 as it is, that is 3.33 ohm, and R2 as it is, that is 3.33 ohm to B. So now in between R1 and R2, so this is R1, R2, R3 and R4 are in series. So you can get here 3.33 plus 3.33, you can get 6.66 ohm. Similarly, from B, you're having one 10 ohm resistor and 3.33 are in series. So you can get 10 plus 3.3 is nothing but 13.33 ohm. Similarly, here at this, from A to here, 10 and 3.33 are in series, so that you can get 13.33 again from here. 13.33 ohm resistors are in series. So now we can see this R1, that is 3.33, 6.66, 13.33 are in delta. We need to transform this into star. You can get star values like this. In between there is one resistor, again in between here one resistor, here we get one resistor. So now the circuit which looks like this. From A, you have R7, R8. In between R7 and R8 there is R9. Okay, so this is R7, R8, and this is R9. R9 which is connected in series to 13.33 ohm. R9 which is connected in series to 13.33 ohm, and this R8 is in series with 3.33 ohm at B, and this 13.33 and R9 which is connected parallel to this like this. So now how will write R7? R7, this point R7 is given by adjacent values of resistors are 3.33 and 13.33. You can get 3.33 into 13.33 divided by 3.33 plus 13.33 plus 6.66. R7. Give me a second. 3.33 into 13.3. 13.33 plus 3.33 plus 6.66. You get 1.903. Oh, that is R7. 1.903 ohms. Similarly, this R8 adjacent values are 3.33 and 6.66. So that R8 you can get it as 3.33 into 6.66 divided by sum of all the resistors, that is 3.33 plus 13.33 plus 6.66. You get, one second, into 6.66 divided by 3 plus 6.66 plus 13.33. 0.9510 ohms. This R8 is 0.9510. So now R9, this R9 adjacent values are 6.66 and 13.33 into 6.66 divided by 13.33 plus 6.66 plus 3.33. 3.806. R9 is 3.806 R9. That is nothing but 13.33 into 6.66, and sum of this 13.33 plus 6.66 plus 3.33 can get 3.806 ohm. So now we can easily reduce the network. This 3.806 and 13.33, these two are in series, and R8 and 3.33 are in series. So that we can get now from A. So we have R7, that is 1.903 ohm, is in series with a parallel combination of these two at B here. So this is 3.806 plus 13.33. Right here, 3.806 plus 13.33. That is nothing but, you can get the value, plus 13.33, 17.148. 3.806 plus 13.33. Similarly, in upper end, 0.9510 plus 3.33. 4.284 we can get. So now we get the equivalent resistance between A and B. That is, from A you have 1.903 ohm, and here you get one equivalent value of resistor. These two are connected in parallel, so that R equivalent is given by 4.284 into 17.14 divided by 4.284 plus 17.14. 4.284 into 17.14 divided by 4.284 plus 17.14. 3.427. 3.427 ohm. So that R equivalent is, that is A to B. There is only one resistor, that is R equivalent. By adding this 1.903 plus 3.427 plus 1.903, you can get 5.33 ohms. This is the answer. So I hope you're getting this problem. If you're having any doubts regarding this problem, feel free to write in the comment box. Only the thing is that you should remember one logic. 3 same resistor na delta del connect ಮಾಡಿಬಿಟ್ಟು ಸ್ಟಾರ್ ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಡಿವೈಡೆಡ್ ಬೈ 3 ಮಾಡ್ತೀರಾ. 3 ಸೇಮ್ ಸ್ಟಾರ್ ವ್ಯಾಲ್ಯೂಸ್ ನ ಡೆಲ್ಟಾ ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಮಲ್ಟಿಪ್ಲೈ ಬೈ 3 ಮಾಡ್ತೀರಾ. It is very easy problem. Just go through that once, practice again. If you're having any doubts, feel free to write in the box. Thank you so much for watching this video. If you like this video, do subscribe and share maximum. Have a nice day.